Smart Christian Velasquez, and today we're going to explore the different forms of memory. So, memory hierarchy is a critical part of any digital computer storing both programs and data. It is categorized into two types. Main memory, also known as RAM or random access memory, which directly communicates with the CPU, providing fast access to data for ongoing tasks. Auxiliary memory like magnetic disks and tapes, which serve as backup storage, offering much higher capacity but slower access speeds. The memory hierarchy organizes all the storage devices in a computer system, ranging from the slower but larger auxiliary memory to the relatively faster but smaller main memory. This structure ensures efficient data management, optimizing speed and capacity to support overall system performance. And as you can see on this diagram, illustrates the memory hierarchy in a computer system. At the top, auxiliary memory includes devices like magnetic disks and tapes, which provide larger but slower backup storage. And these are managed by the I/O processor, which handles the data transfer between auxiliary memory and the main memory. The CPU directly accesses main memory for fast data retrieval and stores frequently used data in cache memory, which is even faster. This layered structure ensures efficient access to both short-term and long-term storage, optimizing performance.
What is RAM? Random access memory is a type of computer storage that temporarily holds data and application, allow rapid access and modification, and volatile or lost data when power is turned off. The RAM integrated circuits chip are further classified into two possible operating modes, the static and the dynamic. Static RAM or SRAM, the primary composition of SRAM are flip-flops that store in binary information. The nature of the stored information is volatile. It remains valid as long as power is applied to the system. Static RAM is easy to use and takes less time performing read and write operation as compared to dynamic RAM. SRAM is typically used in cache memory, CPU register, and small, high-speed memory application. Type of SRAM: asynchronous SRAM, synchronous SRAM, and the pipeline SRAM. Dynamic RAM or the DRAM. Dynamic RAM exhibit the binary information in the form of electric charges that are applied to capacitors. The capacitors are integrated inside the chip by the MOS transistor. The dynamic RAM consumes less power and provides large storage capacity in a single memory chip.
ROM, read-only memory, is a non-volatile memory used in computers and electronic devices to store permanent data and firmware. It retains information even when the device is powered off, making it crucial for both processes and essential system function. Data in ROM is typically written during manufacturing and cannot be easily modified. However, there are variants like EEPROM and flash memory that allows us reprogramming. ROM is commonly found in devices like computers, smartphones, and appliances, ensuring that the critical software necessary for operations remains intact and ready for use whenever the device is turned on. Overall, it plays a vital role in the functionality and stability of electronic system.
What is auxiliary memory? Auxiliary memory is a type of memory in a computer that stores things we don't need to use right away but still need to keep safe for later. Think of it like a long-term storage box where you put things you don't use every day but don't want to lose. It's lower to access but it can hold a lot more stuff compared to the computer's main memory. Here are the two types of auxiliary memory. Magnetic disk. These are like the hard drive in your computer. Imagine them as spinning disks with data written on them in little circles called tracks. These tracks are divided into smaller sections called sectors. It's a little bit like how a record player works, where the needle moves in different parts of the disc to read information. The cool thing is, these discs can stack together to save even more information. Magnetic tapes. Think of, think of this as old school VHS tapes but for computer. They used to store big chunks of data for a long time, like backups. When you don't need instant access to your data but want to keep it safe, magnetic tapes are perfect for that. They store data in blocks and can be rewound like a tape in a cassette player. So why do we need auxiliary memory? Well, because it offers us a lot space at very low cost, even though it's lower than other memory types. Like RAM or cache, it helps us store tons of data for a long term. This memory is like a reliable warehouse where we can go back and grab important things when we need them.
What is an associative memory? Associative memory, also known as content addressable memory, is a specialized type of memory unit that allows data to be accessed based on its content rather than a specific address. In associative memory, when a write operation occurs, the system does not require an address. Instead, it autonomously finds an available location to store the data. During read operations, the user specifies the content or part of the content they wish to retrieve, and the memory compares the input in a parallel with all stored words with identified matches. The architecture of associative memory includes a memory array and a logic for M words, with n bits per word, featuring functional registers such as an argument register, which holds the input data, and the key registers, which mask the certain bits to refine the search. If the key registers contains all ones, the entire argument is compared. Otherwise, the only specified bits are checked. When a match occurs, the corresponding bits in the match registers is set to 1, indicating a successful retrieval. This parallel comparison capability makes an associative memory particularly efficient for applications requiring rapid data access, distinguishing it from the traditional memory systems that relies on a specific address for data retrieval.
Today, we're talking about the cache memory. Cache memory is small and fast temporary storage data. It is located near on the CPU itself. Ito ay madali at mabilis ng pag-access ng data. Kumukonsumo ito ng mas kaunting oras sa pag-access compare sa main memory. Nag-i-store ito ng programs na pwedeng gawin sa maikling panahon at nag-i-store rin ito ng data para sa pansamantalang paggamit. The characteristic of cache memory is that it can retrieve the data almost instantly. It can also utilize high-speed SRAM, making it faster 100 times than the main memory, which relies on slower DRAM. Cache memory is placed between the CPU and the main memory. The block diagram for cache memory can be represented. It is the fastest component in the memory hierarchy and approaches the speed of CPU components.